Assalamu alaikum. Today we will start with part 1 of our lesson Functions Generalities. Objectives. At the end of this video, students will be able to define a real function of a real variable, find the domain of definition of a function, calculate f of a where f is a given function defined algebraically and a is a point in the domain of definition of f. Recognize the representative curve of a function. Define a centered interval at 0. Study and interpret the parity of a function defined graphically and/or algebraically. Materials. Be ready. Before you start, please prepare the following materials: textbook, pens, draft papers, copybook, and a calculator. Real function of a real variable. Definition 1. Let x be a real variable such that x belongs to an interval d. A real function f of the real variable x is a mapping from d to r, where d is a subset of r or d is r itself. That means f associates to each real number x belongs to d one and only one real number y belongs to r. We write it y equal f of x, we read it f of x. We write from d to r, for every x, we get f of x equals y. The two notations f and f of x are different. The first is the name of a function, while the second is the image of x by f, where x belongs to d. The set D is called the domain of definition of f. Example 1. Let x be a real variable and f be the relation that associates to x the variable y equal f of x. Which of the below relations is a function on R? 1. We have f of x equals x minus 1. 2. F of x equal 1 over x. Solution. 1. F is a function on R since for every real number x belongs to R we have one and only one image. While in 2, f is not a function on R because 0 belongs to R, while f of 0 cannot be calculated since f of 0 equals 1 over 0, which does not exist. So f is not a function on R, but if we exclude 0 from the domain of definition, f will be a function on minus infinity to 0, union from 0 to plus infinity. Domain of definition. Definition 2. The domain of definition of a function f is the set of values of the real numbers x such that f of x exists. The domain of definition of a function may be given, otherwise it must be determined. The domain of definition is denoted by d of f, and d of f is a set x such that x belongs to R such that f of x exists. Example 2. Find the domain of definition of the following functions below. Solution. First of all, f of x is a polynomial function, so f of x is defined for every x belongs to R, so d of f equal R. The interval form is minus infinity to plus infinity. In the second case, here we have a rational function. It is in the form of a over b, so it is defined whenever the denominator is different from 0, so x is different from 0, then d of g is negative infinity to 0, union from 0 to plus infinity. 3. Here we have an irrational function, radical x. This function is defined whenever the number under the radical is positive, greater than or equal 0. So h of x is defined whenever x is greater than or equal 0. So d of h equal 0 close to plus infinity. Application 1. Find the domain of definition of the functions below. 1. F of x equal x over x squared minus 1. 2. G of x equal radical x squared minus 4. Please pause the video and try to do it by yourself. Solution. F of x is a rational function, so f is defined whenever the denominator is different from 0. So x squared minus 1 different from 0. We factorize the left side to get x minus 1 times x plus 1 different from 0. So x different from 1 and x different from minus 1. Therefore, d of f is minus infinity to minus 1, union from minus 1 to 1, union from 1 to plus infinity. In part 2, we have an irrational function which is defined whenever x squared minus 4 is greater than or equal 0. We factorize the left side to get the following expression. Here, to know the values of x, we must do the table of signs. So, when we do the table of signs, we get that g is positive when x belongs to minus infinity, minus 2 union from 2 plus infinity. So d of g is minus infinity to minus 2 union from 2 to plus infinity. Representative curve of a function. Definition 3. Consider a function f defined on the interval I equal ab by the equation y equal f of x. The set of points M of coordinate x, y such that x belongs to I and y equal f of x is called the graph of f. As you see below, this is what we call the graph of f. Here is the point M that belongs to this graph. M has its abscissa x, belongs to the interval AB, and its ordinate is f of x. How to draw the graph? In order to draw the graph, we use in general several particular points. To draw the graph, we make a table of two rows. In the first row, we have x, the values of x belonging to AB, which is the interval I. In the second row, we have the values y equal f of x. For example, a belongs to the interval AB. We calculate f of a. Now we take the point A of coordinates a f of a and we locate it on the orthonormal system. Second, we take another point, for example x1. We calculate f of x1. We name it m1 and we locate it again. x2, f of x2, we locate m2 and so on. So we get several particular points. After locating several particular points, now the line joining these points in order of increasing values of x is called the representation of f on I. After locating the points, when we want to join these points, we start from increasing values of abscissa. So we start from the smaller abscissa to the greater one. Example 3. Given the function f defined on minus 2 by f of x equal x plus 1. Draw the graph of f. Solution. First of all, in order to draw the graph, we take several particular points as we see before. For x equal minus 2, f of minus 2 equal minus 1. For x equal minus 1, f of minus 1 equals 0, and so on. Now, we locate these points on the orthonormal system like this. After we locate the points, we start joining the points in increasing order. Please note that the points are collinear, so the curve here is a part of a straight line. So the graph of f is a part of a straight line. Application 2. Given the function f defined on minus 2 by f of x equal x squared, draw the graph of f. Pause the video and try to do it by yourself. Solution. First of all, we draw the table to take several particular points. Here we take 5 particular points. For x equal minus 2, f of minus 2 equal 4, and so on. Now we locate these points on the orthonormal system. After locating the points, we started joining these points in increasing order. So we get a curve since the points are not collinear. This is the curve of f. So the graph of f is a part of a curve.